Welcome, everyone. Today, we are diving deep to decode the language of financial markets. I'm thrilled to introduce you to Kronos, a unified, highly scalable time series foundation model that has been built exclusively for quantitative finance. As you'll see, this open-source model delivers state-of-the-art performance across everything from forecasting and volatility estimation to synthetic K-line generation. You might be wondering, why do we need a new model? The truth is, general-purpose time series models simply fail in finance. First, there's a massive data deficit. Financial data makes up less than 1% of the pre-training datasets for major models like Morai, Kronos, and Times FM. Second, there is a structural mismatch. Generic models just can't handle the extreme non-stationarity, intricate price-volume dependencies, and low signal-to-noise ratios unique to K-line data. Because of this, they routinely underperform specialized, non-pre-trained models in core financial tasks. That is exactly why Kronos was created. It is a purpose-built foundation model, pre-trained from the ground up on a highly curated financial corpus. We are talking about over 12 billion K-line records sourced from 45 global exchanges across more than 30 countries. It supports 7 different time granularities, from 1 minute to weekly intervals, and covers multiple asset classes including equities, crypto, and forex. The core focus here was to explicitly interpret open, high, low, close, volume, and amount data, or OHLCVA, as a compact, information-dense language. So, how does Kronos actually work? Phase 1 is all about tokenization. Kronos transforms continuous, multidimensional OHLCVA inputs into a discrete language by structuring them into token sequences. We use a hierarchical structure where each K-line is quantized into a coarse subtoken to capture the principal structure, and a fine subtoken for residual refinements. To make this work smoothly, we utilize binary spherical quantization, which bounds the quantization error and prevents the model from being thrown off by extreme market outliers, like flash crashes. Moving into Phase 2, Kronos uses autoregressive modeling to predict multi-scale market dynamics step by step. Relying on a decoder-only transformer, the model leverages sequential dependency. This means it explicitly predicts the coarse scaffold first, and uses that to condition the prediction of the fine details. Thanks to fused embeddings and causal self-attention, we ensure that every prediction is rooted strictly in robust historical context. When we put Kronos to the test, the results showed comprehensive dominance. We evaluated our models, Kronos large, base, and small, against 25 state-of-the-art baselines, including zero-shot models and generative architectures. The takeaway? Kronos consistently outperforms all specialized baselines simultaneously, excelling in both predictive tasks like forecasting and generative tasks like synthetic data creation. Let's look specifically at price forecasting. Evaluated on a strict out-of-sample test period starting from July 2024, Kronos established an entirely new standard. In fact, Kronos achieved a massive 93% improvement in rank IC compared to the leading time series foundation model. Furthermore, it delivered an 87% gain over the absolute best-performing, non-pre-trained full-shot baseline. When it comes to risk modeling, predicting high-frequency realized volatility requires a deep understanding of market variance and heavy-tailed distributions. Kronos proves that deep learning can successfully surpass classical financial mathematics. It achieved a 9% lower mean absolute error than established econometric models like GRCH. But Kronos isn't just a predictive tool, it is also a powerful generative engine for backtesting and market simulation. The synthetic data it generates perfectly mimics real-world diversity without suffering from mode collapse. It achieved a 22% improvement in generative fidelity, measured by discriminative score, easily beating out leading generative models like TimeGAN and Diffusion-TS. Of course, in the quantitative world, the ultimate goal is translating data science into pure alpha. In real-world investment simulations, specifically top K/drop-N portfolio construction on the Chinese A-share market, the signals generated by Kronos translate directly into highly profitable trading strategies. Kronos secures the highest annualized excess return and information ratio, vastly outperforming the market index and competing AI signals. An exciting discovery during our development was confirming that neural scaling laws hold true for financial time series. We tested 3 sizes: Kronos Small at 24.7 million parameters, Kronos Base at 102.3 million, and Kronos Large at 499.2 million parameters. We found that increasing the parameter count strictly yields monotonic improvements in both reconstruction quality and downstream forecasting accuracy. Another brilliant feature of Kronos is how it utilizes test-time compute. Because Kronos operates on a probabilistic generative framework, you don't need to retrain the model to improve its accuracy. By generating multiple future trajectories using Monte Carlo rollouts and averaging the values, the prediction variance drops. This allows practitioners to actively trade computational cost at inference time for higher, more stable predictive accuracy. You might be asking, why not just predict continuous prices directly? The answer lies in the advantage of discrete sequential modeling. Mapping infinite states into a finite, discrete vocabulary forces the model to learn robust structural patterns instead of overfitting to market noise, improving sample efficiency. Furthermore, our sequential approach of predicting the coarse token before the fine token heavily outperforms trying to predict both at the same time. Financial markets are famous for fat tails, those sharp directional changes and extreme volatility spikes. Standard quantization methods usually fall apart during these high-stress events. However, Kronos's hyperspherical geometry precisely captures and reconstructs these long-tailed microstructure events. As demonstrated during the Trump trade war market drop, the model remains fully aware of severe liquidity shocks. To summarize, Kronos represents the new open-source standard for quantitative finance. It offers a unified framework handling forecasting, volatility, and generation, all while respecting the structural realities of OHLCVA data to deliver proven alpha. Best of all, Kronos is publicly available to the quantitative finance community right now on GitHub. Thank you for watching.